Problem of today, maximum average subarray. So given an array ARR of size n and a positive integer k, find the subarray of length k with the maximum average. Okay, so example 1, input k is equal to 4, n is equal to 6. So we need to find the maximum subarray of length 4, which is having the maximum average. Okay, we need to find the maximum average subarray of length 4 in this. So here 1, 12, minus 5, minus 6, 50 and 3. Okay, and among this we are given here as the subarray start from the index 1, and here that's the answer. So one thing to note that there is a bit of problem because in our question, in our code, we are returning a int value, and in our sample test case is given the output is given as that subarray value. So there will be a problem what we need to return, and just expand the driver code, and here we are getting one index. This is the starting index. So what we need to return from our function is the starting index, which is not properly provided in the question. So what we have to provide the starting index of our maximum average subarray. So from where our subarray starts, that index must be returned by our this helper function. So that's what this problem asks us to do. We need to return the what this function asks us to do. We need to return the starting index. Now k is equal to 3, n is equal to 7, same way. So one thing that we can note is that suppose we are having so many numbers. Say we are having so many numbers: a1, a2, a3, a4, a5. When this and we are also trying to find a subarray of length, say 3. Okay, so we have this subarray, we have this subarray, we have this subarray. Okay, we have one subarray of a1, a2, a3, and it will be a1 plus a2 plus a3 by k, and this will be a2 plus a3 plus a4 by k, and the other one will be a3 plus a4 plus a5, and this k is constant in all of these values. This k is like a constant. So in order to have the maximum average, our sum has to be the maximum. This sum has to be the maximum. a1 plus a2 plus a3 has to be the maximum, or a2 plus a3 plus a4 has to be the maximum, or a3 plus a4 plus a5 has to be the maximum, irrespective whatever will be the value of this k. So we can just break down our problem into finding the maximum sum subarray of length k. We can just find to get rid of all those floating point values or dividing problems. We just try to find that subarray which is having the maximum sum. So our result will be like we will be finding max of maximum subarray of length k. So we will be trying to find the maximum sum subarray of length k. So the step here is, first of all, we need to maintain the prefix sum. So let's start from this 1, 1, 12, minus 5, minus 6, 50 and 3. Okay, 50 and 3. So first, and here the k is 4. Okay, here the k is 4. So first what I do means, I first of all calculate what is this maximum sum, what is this sum. So what is this sum? 1 plus 12, 13. 13 plus minus 5 is 8. 8 minus 6 is 2. So the first window or the first subarray of length k is giving me a maximum sum of 2, and this is ending at a index 0, 1, 2, 3, 4. This is ending at index 4. So let's use this information in order to calculate for the remaining windows as well. So let's say first we just traverse through the first k window, the very first window of length k, and we have seen that its max is, okay, its max is 2, and the index is, let's say index is I and it is 4. This index I means the ending index. Okay, now we just start our traversal from this position. So now what our also our prefix sum is 2 now. Okay, so what is the next after adding this 50? After adding this 50, like our size increases this much, or size increases this much, which is, it becomes of length 5, but we need length 4, so we need to subtract this one, and we can easily get it by doing array of, so suppose we are at a particular index j, we can easily do by array of j minus array of k minus j. So what is k? K is 4. What is j here? 0, 1, 2, 3, 4. I made a mistake. This will be 3. Okay. So 4 minus 4, 0. That means we are removing this and considering this window for now. So our prefix sum was 2. We added 50. We will be adding 50 minus 1, which is 49, plus 2, 51. And this 51 is greater than max. So we update this with 51. And our ending index now becomes this one. It now really becomes 4. That was my mistake. This has to be 3 for the first window of size k, and after that, like, it becomes 4. Okay, now we move forward. We are at this index, so we will be just applying this. So prefix sum, that is prefix sum plus array of j minus array of k minus j. Now we have to get rid of this sum. So that will be what is the prefix sum? Prefix sum is 49. 51. Prefix sum is 51 plus what is this value? 3 minus what is the value? 12. So 51 plus 3 is 54 minus 12 is 42. Is 42 greater than this one? No. So we get the ending index of our window. So how to find the starting index of our window? It will be the ending index I minus the length plus 1. Why plus 1? Because we are considering 0 based indexing. So it has to be like that, because all these are 0 based and we have to do plus 1. It can be like 4 minus 4, 0 plus 1. So 12 minus 5 minus 6 and 50 will be that window what we are looking for, and that's itself. So let's have let's try to code our approach. So if array is null or n is less than 0 or n is equal to 0 or k is greater than n or k is less than or equal to 0. Just a base case that I always add. We don't want to specifically add it because n will always be at least 1. But let's do that and say it's some minus 1 value. No values. Now what and all we need? We were saying we need a prefix sum for length k, which is equal to 0 at first. We need max possible sum. let's have it 0 itself. Don't need to make it as a integer dot max small value. No, integer dot min value, that's not required. Now int max possible ending index, which is also, let it be 0. Now first we will be calculating for the very first index. Okay, so we will be calculating for the very first index. For int I is equal to 0, I is equal to 0, I less than k, I plus plus. So prefix sum for length k plus is equal to array of I. So now we got our prefix sum for the first k length subarray, the very first. Okay, that is this one. We got it. Now let's assume that that is the maximum possible sum that we have seen so far. So prefix sum for length k and the possible ending index is equal to k minus 1. Why k minus 1? Still it's based on 0 based indexing. Okay, like this will be running from 0 until I becomes equal to 3. So it's based on 0 based indexing. Now we will be calculating for the remaining array values and considering the window of size k. Okay, so for int k is for int I is equal to k, I less than n, I plus plus. So what we have done, what we are told, we will be updating our prefix value with this one, prefix value plus array of whatever be our current index minus array of k minus our current index. So here it will be prefix sum for length k plus is equal to array of I minus array of k minus I. Now if this is greater than our maximum possible sum that we have seen so far, we will be updating both its maximum possible sum and its maximum possible ending index, and ending index will be I at that case. So if prefix sum for length k is less than, sorry, it's greater than max possible sum, update max possible sum is equal to prefix sum for length k and max possible ending index will be I. Now just return. Now we got the end. So we got this end. This will be 0, 1, 2, 3, 0, 1, 2, 3, 4. So we got our end as 4 at this case, and our window start from first index until 4 index. So it will be max index minus the length, the k, it will reach here plus 1. So we will be getting the starting index. So max possible ending index minus k plus 1. So that's what our problems looks like. So first of all, here what we need to return means our this findMaxAverage function returns means it will be the starting index where our maximum array subarray starts. Don't get confused with this output that is given. We need to return that starting index of the maximum average subarray. And also, like our k here is constant, and in order to find the maximum average, we must have the maximum sum for that particular subarray. So instead of getting rid of all those floating points, everything, we can just change our problem for finding the maximum average, maximum sum subarray. So we make use of a prefix sum, the maximum possible sum that we have seen so far, and its ending index where we have found that maximum possible sum. So at first, for the very first window, we will be finding our prefix sum. We will be just storing all these values to the maximum possible sum and our maximum possible ending index. Now we will be calculating the prefix sum accordingly, and will be for the rest of the indexes or for the rest of the values, and we will be updating the values for the maximum possible sum, and our result will be the index minus k plus 1. So here the time complexity will be big of k plus big of the remaining n minus k. We can say it's big of n, and we are not making use of any extra space, so it will be big of 1, a constant extra space. Let's compile and run. We have a runtime error. Okay, it's at the 53 k minus we got k minus I minus 1. Why we got it as, oh sorry, it must be I minus k. That's my mistake. It has to be I minus k, because I will be greater than k. Yeah, must be I minus k. Sorry, that's my mistake. This must be I minus k, not k minus I. Let's also some random test case. That's also providing the same, and let's submit. So the time complexity will be big of 1, space complexity will be a constant big of 1. Sorry, time complexity will be big of n, where n is the length of the array, and space complexity will be big of 1, where we are not making use of any extra space. So that's the problem of the day, maximum average subarray.